Chapter 5 Gas-Powered Cycle Gas Turbines. In Chapter 5, we are going to go through 6 subchapters, including the introduction, as-standard cycle assumptions, the simple Brayton cycle, and methods to improve simple Brayton cycle via regeneration, intercooling, and reheating. By the end of this chapter, you should be able to understand the concept of gas-powered cycle, able to identify and analyze simple Brayton cycle and Brayton cycle with performance improvement method such as regeneration, intercooling, and or reheating. Working fluid for gas-powered cycle will be ideal gases or in specific atmospheric air. There are 2 gas-powered cycle types that will be covered in MEC251 thermodynamic. They are gas turbine engine, which will be discussed in the current chapter, and internal combustion engines, ICE, that will be discussed later in chapter 6. Most common basic operation of a gas turbine engine is Brayton cycle. The actual Brayton cycle operation is actually an open cycle that is comprises of compressor, combustion chamber, and turbine. The compressor will take the fresh atmospheric air to be compressed. The compressed air will then flow to the combustion chamber, where the high pressure air will be mixed with fuel and combusted, resulted in high temperature gas, which is mixture of air and fuel. The gas will then be expanded in the turbine, producing work before the gas exiting the turbine is being exhausted to the atmosphere. The process will then repeated as the fresh air will enter the compressor again. However, for the ease of analysis, this open cycle can be modeled as a closed system by utilizing the air standard cycle assumptions. In the air standard cycle assumptions, the air, which is the working fluid, is assumed to behave as an ideal gas. We are going to assume that the heat addition process is coming from the external sources, although we know that in the actual process it will occur through combustion. For this, instead of combustion chamber, for the ideal case, the heat addition is through the heat exchanger. Despite the exhaust process, we will now assume there is a heat rejection process that restores the working fluid back to its initial state. During this process, we will assume it is through the heat exchanger, and all of the processes in the cycle are internally reversible or in ideal conditions. Can you spot the difference between the actual Brayton cycle with the cycle that applies the air standard cycle assumptions?